Looking at showing that two integers R and S are relatively prime if and only if there exists two integers K and L such that KR plus LS equals to 1. This is actually one of the proofs that the book didn't do completely. And it's got some good methodologies for your homework, so that's where we're going to start. What's the hypothesis? What are our two integers R and S? Well, I guess going forwards. Let R and S be two integers. How about that? Let me tell you which one this one is in the book. I think they did part of it, and I'm doing the rest of it. Theorem 3.
Proof 3, you said? Or, oh, yeah, there it is.
It's kind of a combination. Theorem 3 isn't relatively prime. You have to combine that with the middle. It's actually a pair of integers R and S are relatively prime if they have no common divisors except plus or minus 1. Combining that with theorem 3 to get the linear combination. And so that would be paragraph on page 220, the third from the bottom. Combining that with theorem 3. But that's where we're headed. So let R and S be two integers. We're going to go forwards. So what's the assumption to go forwards on that one? Yeah, assume R and S are relatively prime. What does it mean for integers to be relatively prime? Yeah, they have no common divisors other than 1, minus 1. The greatest common divisor is going to be 1. Now, we're going to assume theorem 3, so what does theorem 3 tell us?
Any two non-zero integers have the greatest common divisor that...
A linear combination, right? So there exists, we got R and S for doing T and U. In the integers such that 1 is equal to TR plus S times U. No, maybe we should have used K and L. Yeah, then it matches. So the first direction's easy. Now let's go back the other direction. Assume that there exists integers K and L such that, and we have the linear combination.
Well, straight from that, can't you just say that then their greatest common divisor is 1?
Just because it is a linear combination. Yeah. You can't go straight to it as the greatest common divisor. So what we're going to do is we have to show that 1 is the biggest common divisor, the greatest common divisor. So let's just pick any other common divisor. What do you want to call it? A letter, not a number. M. Let M be in the integers such that M divides. Oh, I don't like that. Hey, shortcuts when it's connected to the projector do not work. I actually have to go and get it. I did both of them, and it's giving me absolute value and norms, which is not what I want. So let's go see.
Which is like star for that?
This one? Yeah, there it is. Close that one.
Hold control and do MID.
Control, you said, and MID?
No, I guess it's because are you holding control when you do it?
Yeah, I did.
I guess it's just
I'm
'cause you're-
connected to the projector.
Yeah, with marking it.
Everything is wrong. Yep. So that M divides R and M divides S, right? So we have a common divisor. What does it mean for M to divide R?
No, there exists something like something.
Yeah, there exists something social, something, I like that. There exists, what should we call your something?
Q.
Oh, we don't, okay, Q. We'll go with A for the next one. There exists a Q in the integers such that MQ is equal to R. And since M divides V, there exists an A in the integers such that,
Where do you come in? Just pass that to
oh, I want it to be a B. There we go. Such that S is equal to MA. Plug these into the linear equations. And we are done, essentially. We have KR plus LS is equal to, R is equal to MQ, so we have KMQ, plus S is equal to MA, so we have LMA. Is there anything we can factor out from both of those? M. So it's KQ plus LA, but that is just equal to M times some W.
Where?
I know you like that. Where W is equal to KQ plus LA is in the integers, because the integers are closed under addition multiplication. They form a ring. What is this telling you? M times W equals to 1. So what is this telling you about M? Well, it divides into 1. And if M divides into 1, that means that it's either equal to 1 or equal to minus 1, right? Oops. Plus or minus 1. We started with any common divisor. So any common divisor of these two numbers, R and S, is either plus or minus 1. So what is the greatest common divisor of that? It's going to be the positive one. Negative 1 is smaller than 1, so it's not the greatest common divisor. Here, what you guys have to notice about here is when we started with the linear combination, then we used the properties of division to plug in values so that I can factor something out. That's going to be the trick on half your homework. The other half of your homework, you're going to start with these values here, S equals to something and R equals to something, and you're going to combine them together to get a linear combination. So you're either going to start with the linear combination and plug in these values, or you're going to start with these values to arrive at a linear combination. It's going to be one or the other of those two on your homework. That's the tricks for your homework. That's what you're doing in your homework. It's really not that hard. You just have to figure out which way it goes, which one, you know. So let's look at number 3 here. How come it went to number 3? Oh, because this, I removed the proof. Let me fix that. There we go. Show that if C divides A and C divides B, then C divides the linear combination AX plus BY for all X and Y in the integers. How do I go about showing this? What's the hypothesis? Let C divide A and C divide B. just right where A, B, and C are in the integers. Now, we have to get our x and y, so let x and y be any values in the integers. Our goal is to be able to show that C divides AX plus BY, but remember, that means what? If you have C divides AX plus BY, that says C times something is equal to AX plus BY. That's our goal. So we're looking for the linear combination on this one. That's where we're headed. What does it mean for C to divide A? There exists, I don't know, a u in the integers such that C times u is equal to A. If C divides B, what do we know? Yeah. What do you want to call it? Okay, there exists a W in the integers such that CW is equal to B. So now let's start with our AX plus BY. Do we have anything for A? What is A equal to? CU, so we get CUX. And B is equal to what? CW, so we have CWY. Now, is there anything that you can factor out? Oh, yeah. So we have a C, we have a UX plus WY. But where does UX plus WY live? In the integers. Yeah, you do need to know it's in the integers because that's what it means. C times an integer. Oh. It's all gone.
It's forever.
No, can you go back?
No, you can't.
No. It only goes back once.
You have history.
It only goes back once. In later sections, it will go back more times. Let's see.
Yeah, one day.
Yeah.
3 years, but.
No, they have promised that in later sections. Well, yeah. We'll fix this one. I'll retype the first one while you guys are working on that last one.
Everyone. Oh. Because everyone knows you can't undo this.
No, if I had typed only one thing, I could undo it, but not two. Let's see A, B, B in the integers.
Good, now we have to make sure we really have to put in.
Yeah, the story to this is save often.
Remember Krista saying like every sentence?
5 seconds.
Every save. Oh, I've been sitting save.
I don't blame her, actually. So since C divides A, what do we call it?
U.
There exists a U in the integers such that CU is equal to A. And since C divides B, there exists W in the integers such that CW is equal to B. And then we had AX plus BY is equal to CUX plus CWY, which equals to CUX plus BY.
WY.
Oh, yes. WY, which is equal to C times R, where R is equal to UX plus WY is in the integers. Yeah, save. Thus, we see that C divides AX plus BY. Okay. What I want you guys to do is look at your homework problem number G8. Yeah, this is actually the hardest one of all your homework problems. No. For this section. For this section.
Valid question.
You have to do something. You have to show that A plus B is equal to, and they give you some properties. And remember, these are principal integral domains. That means they're sets. So that means that you have to show that A plus B is contained in D, and you have to show that D is contained in A plus B. Where you're looking at the set A plus B is going to be the set of all linear combinations of A and B. So it's going to be TA plus RB, T and R can be integers. So that's where the linear combination idea comes in. So go ahead and start playing with this. Read over what they give you in the hypothesis, see what you get. I'm going to come around and look at your outlines. I know some of you said you haven't got them done yet. That's okay. You can always show them to me next time if you don't have them done this time.
This will take forever.
It is. I actually did these while I was sick, and it took me a couple hours, and I didn't know if that was a function of my being sick or just the length of the chapter, but it really did take me a long time to do that one. Oh yeah, I didn't have anything else. I will tell you that the next chapter is also a long one, and then the last one is not so long.
We're only at 2 minutes.
Yeah. Just look at this next week. And then makeup test day, and then review for the final. And then, well, review for the last test, and then the last test. No final result. It's very difficult. I like your black suit. Your black suit? I didn't get it.
I have a question.
Blah.
That's kind of questionable.
I
I need
really
to
like
reread
this
it and I
group.
will ask you.
Okay, I heard your question about the fun.
So it's 2 weeks until?
Oh, no, you don't want.
2 weeks until
Oh, yeah.
finals, yes.
What's our first?
Yeah.
Tuesday.
Tuesday? Okay, I'll do it. I would guess.
The first?
But it's not a final, it's just a test. It's test free. It'll be a 1 hour test, but you'll have 2 hours for it stuff, but I'll just write it as a 1 hour test.
So you'll get this 2 for 2 weeks.
Yeah.
It'll be 3 weeks from.
I have no clue what to do with this problem. No, where's it going?
So how are you guys doing?
Literally, I wrote, let the grades come in factor of A, B equal D. That's all I have.
Well, it's obviously true.
Are you just gonna write true?
So it's like, it's past the 12, right?
You showed me 21, I just assumed that was because you didn't have it last week.
Oh, yeah, I did.
Okay.
I'm trying to figure out 4 weeks. Okay.
Why are you trying to do easy?
That's good. That's enough time. What's about that? Open configuration hospital. It's one of these things. This is kind of moments that I didn't. So, what we got here?
I just want to do an easy problem.
Rather do an easy problem than do one of the first ones first, but you're gonna want to work on this one before the last one. Before you leave.
But let's do an easy one.
Wait, no, Tim's out.
And then. Bam, Harry's
Yes,
so
really.
smart.
You're gonna have to say that's pretty dull back of there. Yeah.
Don't even know what this is.
It's in the chapter someplace.
Yeah. Python 3?
You see
No,
yourself
the
at
D
that.
would equal like A
Yeah,
plus dy.
but.
And then that follows that same sequence.
That exactly.
It's
so smart.
We're doing D3 now?
Yeah.
She just told us how to do it.
Slowly open it.
See, that's what I'm
So, luckily.
Oh, thanks for having such support and trust and confidence in you.
No, you guys could have told me how to do it. I didn't care who told me
Thing
how to
is,
do
you were
it.
like,
Someone that
screw
knows.
it up.
That's exactly what I thought.
Oh, I'm joking.
I think that every day, guys.
This is awkward.
Even when we're not, I'm not like, man, I could be so bad.
Why don't you choose to sit on the front row? Okay, now.
I don't understand what we're using.
Mine's on top.
I've got this chapter 21.
Oh,
A plus B is.
Hey, I see things on the board.
Yeah, this is the case.
Yeah, that's basically like from. It's saying that A plus B is this, and so now we're gonna do something. Like, sure. No, I'm gonna just get you the wrong. I say this. This. Right. So how would we write this with an equation based on the fact that
Well, we already know that it's going to be T.
does that mean? Oh. So that's if B divides A and B divides C, right?
I don't know if that's in the middle, or I would do something that's still outside this group. No.
Am I right saying that? This is just trying for me to describe grades and
How can you say this?
that's, don't look at that.
Oh, never mind.
That's just the answer. That's me just writing the question. No, this, like, I'm just trying to write this in terms, so just look at this. Not look at that. Because this does just throw it off the board.
Okay.
So now what?
And then by theorem 3, we know that
I see things going on like that.
For Brody's sake, I'm gonna write this down. I can see it.
Yeah, I know where you're going.
like it.
Sends it to there. You gotta do something with these.
We're doing
Anyway. Remember that.
But like the X and Y, X for A and Y for B.
all these X's and Y's.
Even if you fold your block, we're not happy.
It's no like. No, that's whatever you write.
Open up your file.
Yeah. But where you actually have to sort.
Where X and Y are
Yeah. So now we're gonna be able to do that. Now we need to show A plus B is contained in B.
You can say that you're
Now, how do you describe the thing called this? How do you describe this? How does that describe? Can we write that window? Am I saying that correctly?
way.
Like, am I allowed to say that? Like, is it based into what I'm trying to say? Is it people?
Yeah, I get what you're saying though.
How do I write this in the equation?
Yeah.
Just that.
Oh, well, she has what that is.
Oh, so this just imply.
No. That's the, I don't know.
Wait, did you guys use?
Where's the date generator coming from?
Nice meeting you. How you guys doing?
Probably one. You said it. I'm sorry.
It was pretty full and honest.
That was.
It was truthful and honest.
Okay. Hey, what we're doing was, who wants to help me count to this, Vespers?
I think I actually can.
I think I can
Even though I
too.
always tell you that, and I have done it once.
I'm really sorry. I've done it only one time. But I think the last few
We'll do
Vespers
it.
I found myself in my
Oh,
bed.
so you say you remember that? Oh, okay. So you say how it works. Yeah, but the funny thing is,
That's
like,
like my bed's Vespers.
I saw the comments.
How's it ever had?
That looks good.
Have you actually had a Vespers time to Vespers, or they always been extra weird Vespers? And all this extra stuff
I
going on?
know there's all this.
They like on the
So
outside.
that, where it would be incredible.
Never had them salt.
Incredible.
You only had them salt.
Invaluable.
They have like multiple. I'm pretty sure every cashew you ever had. So I'm just like, why do they want to all salt the main thing?
I know.
It's weird.
But they don't taste like cashew. That's just science, so that's all we gotta do.
Last time it sucked.
No, but like, have you ever had?
Which had to do counting 1,000 people. But like, have like one other person for the job over there.
I'm sorry.
So remember on this, guys, that you have to go two directions to be able to show equality. So what do you
So
got?
I've been able to say this. I've basically said this is this, and this is that.
So, yeah, this is going to be all multiples of D.
And I can say that is all the way down to that.
So D divides A, D divides B. And you also know that there's a linear combination. Don't forget that. Greatest common divisor is a linear combination.
Like,
AX equals B, Y.
But then can you use the same letters for what you use?
Yeah,
Oh.
okay,
Oh, so there's so many letters.
yeah, so I don't know, what do you want to call this one?
A-M,
A-M,
and B-N.
Oh,
Yeah.
wow.
And you had,
And that's by theorem.
X was equal to
Do you want A?
A, and would you have?
dy is equal to B.
dy equals to B. That all
Oh.
comes from the greatest common divisor of A and B is equal to D. Those are the three things that come from that right there.
All right, calculate that I can do. So then,
So now can you replace it?
Oh,
A
yeah, we
with
put
dx,
A and B.
B with dy, plus the d, divide it
Well-
over, you have a 1.
Okay, so now you have to show equality here. So which direction are you trying to show first? This direction or this direction?
which one's easier? Which
I
one
don't know
will
how
that
to
one
get
take us
from what
to?
we have to anything with those cyclic things.
Okay, so let's start with one of them. Which one do you want to start with? Just
The top
pick
one.
The top one. So to be able to start with that, you have to start with, let's see, let's write this over here. You have A plus B is contained in B. So whenever you show set containment, you have to let some value, what's it, I think P we haven't used yet. P has to be some value in there and show that P is in cyclic group of D. What does it mean for P to be in the cyclic group of D? It has a multiple of D. P is equal to D, I don't know, B, or some B in the integers. What does it mean for P to be in this group right here? What does that group look like?
that.
Yeah, P has to equal to one of those. So P equals to TA
So
plus
we can
RB.
just say that that's what A plus B equals at the top in the yellow?
Yeah, that's the definition.
Okay.